Hey everyone, welcome. Come in, grab a seat. I don't know if you're here for the talk or if you're here for the information, but welcome, grab a seat. Hi. Thank you everyone for coming to spend your time in this session with me. Yes, more, please come. I know you could have chosen Troy Hunt, 2 security talks at the same time. Who would have known? But whatever, here we are. I do hope that you learned something from this talk, and more importantly, I hope that you have a bit of fun. I was chatting to someone outside earlier, and it made me realize that maybe not everybody is a cat person. So I just want to get a feel here. How many of you consider yourselves cat people? Okay, that's about half-ish. Nice. Do we have dog people? Their hands went up way faster than the cat people. That's interesting. What are you doing in a cat talk? So there were definitely 1 or 2 of you that also put your hand up for both, which is cool. I respect that because I'm not a cat person. I'm also not a dog person. I love both of them. But I'm more of any animal that wants to give me some affection and get little scritches and I can play with them and cuddle with them. That's what I'm talking about. Whether it's a cat, a dog, a guinea pig, a chicken, a parrot, a pig, anything, I'm there for it. And in fact, when I was growing up, my grandparents had a farm, and on that farm there was a cow, E-I-E-I-O, and it was my favorite cow in the world. I used to call her Bessie because her name was Bessie. And she had this beautiful light brown coat, like you could almost see like red in it if you looked a little bit through the sun. She was a beautiful, wonderful cow. She was huge, probably about this big, although I was a lot smaller then, so she was probably only about there, like an average cow. And I used to wake up in the morning and leave the farmhouse area and go to like where the animals were kept, the livestock area. And on the way I'd pick up like hay or seed pod or something as a little treat for Bessie, and she'd meet me at the gate. And we'd kind of spend the day walking through the livestock area. She'd follow me around and we'd have fun and we'd play. And I'll never forget these little seed pods that I used to take. They were big and black and they were like curved, I suppose, almost like a boomerang. But they didn't have the right profile, so if I threw them, they didn't come back. Except, and this is true, I used to play fetch with Bessie. So I would take a little seed pod, shake it in front of her face, and she would see it, stick her tongue out and try and eat it while I'm showing her this seed pod. And I would throw it. And every word of this is true. She would ignore it. But when I went to go fetch the seed pod, she would follow along with me and then bump it and rub up against me and be fun. And we'd have a great time. She was my favorite cow, which I guess is a really long-winded way of saying, hi everyone, my name is William Brander and I like cats. And cows apparently. In this talk, we're going to talk about security and specifically how to secure modular monoliths. Security is a very broad topic, and security consultants make a lot of money going into very deep detail about specific things. I don't know a lot about security, but I have gathered a set of skills over a career that allow me to teach you how to secure systems that are based on messaging and make sure that they are more secure than they otherwise would be. But because security is a broad topic, I also don't want you to sit here and think that I'm going to cover something that I'm not going to cover. So what I'm going to do is I'm going to tell you exactly what I'm not going to cover in this talk. Then I'm going to tell you what I am going to cover, so that if you are sitting here expecting me to talk about something that I'm not going to do, you don't have to spend an hour sitting here wasting your time. You can go to, for instance, Troy's talk next door. Maybe he's talking about something specific. So the things that I'm not going to cover today, I'm not going to cover any authentication. I'm going to assume that you already have some mechanism of authenticating your users and presenting them with some sort of credential that says, yes, this is who you are. Maybe some sort of token or a cookie that just has a user ID or something like that. I'm going to assume you already have that in place. I'm not going to cover end-to-end TLS encryption. So I'm not going to show you how to set up encryption between services. That should be the bare minimum when you're doing any security with distributed systems. So that's not something that I'm going to teach you about today. I'm also not going to talk to you about how to do token exchanges between components in your system, mostly because how you do the token exchanges is specific to the tool that you're using to issue those tokens. What I will do, though, is I will talk about why you might want to do token exchanges and the implications of doing token exchanges between systems. I'm not going to tell you how to secure your databases, your file shares, your images, your assets, anything like that. That's incredibly boring. I don't want to do that. Nobody wants to sit here for an hour and listen to someone talk about that. And I'm not going to cover front-end security. This is probably a big one for a lot of people. So all of the stuff that I'm going to cover today is about back-end security, security between components that use messaging to communicate with each other. What I am going to cover today is I'm going to cover tracking identity between these modules, why you might want to do it, as well as which ways might be good to do it and which ways might not be good to do that. I will also cover the basics of zero trust in messaging systems. So we're going to talk about why zero trust is important, and then what zero trust means for your threat modeling in your systems after that. We'll also take a look at personalization of data. So personalization, we've got authentication, which is this is who I am. Authorization, I'm allowed to do this. Personalization, I'm not allowed to see this part of the thing that I'm allowed to do. So there's 3 parts there. We are going to touch on personalization of data. We'll also look at, we'll take a look at token expiration. So what to do when tokens expire, because as soon as you do any messaging, there's no guarantee that those messages will be processed when you think they're going to be processed. So you need to be aware of tokens expiring and what you can do about that. Then we'll also take a look at how versioning affects your security, how your security rules can be versioned through your application changes in a way that you don't have any downtime in your system. And then, of course, because I could at least tell from the few hands that did raise, I know there are some of you for the cat stuff, so don't worry, there's going to be plenty of cats throughout this talk. In fact, I'd like to introduce you to the inspiration for this talk. This is my cat, Butterbean. Everyone calls him Butt. Butterbean is the inspiration for this talk because I was working on a zero trust talk. And the premise of zero trust is that everybody is out to get you. They are all assholes and they want you to have a terrible day. That's what he does. He wants me to have a terrible day. He is an asshole. We don't call him Butt because it's short for Butterbean. We call him Butt because it's short for asshole. He doesn't like anybody or anything except my daughter. I'm comfortable to say that nobody in this room would be liked by him because you are not my daughter. He might tolerate you more than he tolerates me because he specifically dislikes me, but he doesn't like anyone except her and food. Now, onto the monoliths. I want to first cover what a modular monolith is so that we're all on the same page, and then we'll work from there about what it means for security requirements. Has anybody worked with modular monoliths? Anybody working currently? Okay, so we've got a few. So modular monoliths are I can't even say that word properly. Modular monoliths, better, are a development technique for building systems. And they sit somewhere on a spectrum of the distributedness of a system. The intention is to address coupling concerns. What do I mean by that? So on the one end of the spectrum, you might have a monolith, where everything is contained within one application. So you want to build the application, cool, you check it out from the repository, open it up in your IDE, start doing development, run it, build it, and everything is there. Maybe there'll be some external components like a database server, a web server, maybe an application server somewhere, but by and large, everything is self-contained within the system. Really nice development experience because it's all in one place. However, what tends to happen with these monoliths and why they have a bad name in our industry is that as you maintain these systems over time, you start to introduce coupling between the parts of the system. So 3 years later, 5 years later, 10 years while you're maintaining the system, it becomes really difficult to make simple changes because the coupling between these components becomes so intense that you can't even just change the way you display a date on the form. This is when we start referring to these as big balls of mud. So they've got great development experience, but they tend to end up with high coupling between the components in the system. On the other end of the spectrum, we'd have something like microservices, perhaps, where every bit of capability, every bit of functionality is deployed as its own independent bit of software that runs. This is really nice from a coupling component because you physically cannot make a direct call from one microservice to another microservice. You have to have messaging between them. And you don't necessarily know when things are going to happen, so you also have to discard the idea of temporal coupling. The downside of this approach is that to get your system running, you might end up having to open 5 applications, 10 applications, 20, 30, 40. I don't know how many applications you have in your system. But to get your system running, it becomes a horrible process of, I've got 20 console windows open that I need to manage. The modular monolith is an attempt at compromising between the two, taking the best of both approaches. So we want the monolith because the development experience is really nice, but we don't want the coupling. So what we do then is we say, well, what I'm going to do is I'm going to have capabilities, modules within my monolith. These capabilities would be things like customer services or shipping or sales. Everything within those capabilities can make direct calls to other parts within that capability, but anything that goes outside of the capability, we have to send a message. So what we would do is we would take a message and we would put it on an implementation of the mediator pattern. The mediator pattern would then say, cool, this message now needs to go to module B. Oh, it also needs to go to module C. So module A doesn't know anything about where this message is going. It just knows this is happening or someone must do this. So I put a message on my mediator bus. That mediator bus then takes it where it needs to go. What this means is that if we decide in the future, for whatever reason, that we have to scale out our system or we have to take a part of our system and move it somewhere else, maybe module C needs to go somewhere different for high availability reasons, or that's a particular part of our system that happens to need to be scaled up, we can take that part of our system, move it out, but it's now no longer in our monolith. Our monolith is still module A, B, and all the rest of the things, but module C is no longer there. How do we get them to communicate? We introduce a message broker between the two. So what would happen is module C would communicate with a message broker instead of communicating with the mediator bus. The mediator pattern would, instead of sending messages directly to module C, put messages that have to go outside of the process onto the message broker. The message broker would then ensure that the message gets to module C. So the modules that remain, A and B, still don't know that module C is not in process. They still think, well, whatever, it doesn't actually matter. It just sends messages. The mediator bus says, oh, hold on, this message needs to go to module C, which is not in process. So I'm going to take this message, serialize it, and put it on the broker, and the broker will send it through to module C. This is exactly the same as adopting kittens. When you get a kitten, you don't deploy them into an app domain. You deploy them, that's the professional term that vets use, by the way. You deploy kittens into a safe room, a room that they are going to learn is their little safe habitat for somewhere between a week to 2 weeks, depending on what else is going on in the environment, how skittish that cat is, and sort of how long it takes for the cat to settle in. Of course, instead of interacting with the cat with an API gateway, you interact with the cat with its name. You talk to the cat. You say, hey, Butt. We used to call him Butterbean before he turned out to be a real asshole. And then instead of having modules within the safe room, you'd have capabilities that you would expose to the cat. You would have, for instance, toys that the cat could play with. You would have food that the cat could eat. You would have a litter box that the cat could do the other half of eating with. And the cat wouldn't use a mediator bus to interact with these components. It would interact with by playing with the toys, by eating, by doing the other half, or by playing with you. Eventually, once the cat has settled into its room, you can then start taking some of these capabilities and putting them outside of the room. So maybe you move the litter box into a second room, the bathroom perhaps. You start moving the food into the kitchen, the toys spread everywhere in the house, and you stand on cat toys wherever you go for the rest of your life. I think we can safely agree that I've conclusively proven that adopting cats is the same as software development. I will not take questions on this at the moment, thank you. Now that we've established that getting a cat is the same as building systems, what happens when we let our cat out? What does it do to the security of our system? How do we ensure that when our cat starts escaping, we can make sure that the cat is safe and secure still? Well, and by cat I mean software. So let's take a look at what happens. How do users present credentials when they use a modular monolith? They would access the system by presenting some type of either token or cookie or something that says, this is who I am. That token gets presented to the system. The monolith says, okay, yes, this is William. Okay, everyone, William is using the system now. Let him do whatever William can do. And that token flows through whatever's happening in the system. Maybe it becomes part of the thread.current thread. You can get the principle that way. This is fine when everything is a monolith. However, once we start taking parts of that system and we move them outside, that thread, that coupling between who made the original request is lost. So when we take a message and module A sends a message, to Module C via the mediator bus and the message broker. Module C takes the message and says, oh, okay, I need to charge William's credit card $100. Who requested this? That information is lost because we've decoupled Module C from the application domain that it's running in. The easy fix, of course, is just to send the identity along with the message, right? So we take the identity, William triggered this event, add it to the message and send it along with the rest of the message, and that's fine. It might be as simple as taking the message object that we've got and add in a property that says this is the user ID that we're going to send along. Asterisk here because we're going to circle back towards the end of the talk and see why this might or might not be a good fit for your environments. But the essential process is that everything that you do within the system should have a user identity associated with it. And this should be true even while your system is a monolith. So this is one of the few things in this talk where I'm going to say, I highly recommend doing this even if you're not going to scale your monolith out at any point. Any messages that you send should include the identity of who triggered that message in some form. You can get it from the context in a modular monolith, but it makes more sense to send it along with the message as well. Because not only does it mean that when you scale part of your system out, you don't have to rewrite everything to now send the user identity, but it also makes it more clear as to what or who triggered every action even within the system. And when you're trying to play detective and see what caused this to happen, it's a lot easier if all the information is visibly available to you. Butterbean also loves having people part of his process. So everything that he does has to involve someone. Usually it's my daughter. So if she would lie and watch TV, he would come and lie on her chest and just be very cute that way. If she was at school or if she was asleep, he would settle for someone else. But everything that he did, there had to be another person involved. So when you get back to your desks, remember that when you send in your messages, make sure that you include some sort of identity in the message before you ship that information off. And this is probably good advice even if you are not going to scale your system out. Let's take a look at authorization. This is Butt on my driveway playing with my daughter when she was very young. This is one of his favorite spots because there's no dogs there. There's little tree stumps where he can sharpen his claws on. There's lizards he can hunt if he wants. This is his little area that he controls. And if I were to go up the driveway, maybe to check for post or to take the dustbins out, he'd be very affectionate while I'm walking up. He'd rub himself on my leg, he'd follow me along. I'd get the post or I'd leave the dustbin outside and I'd turn around. And the two of us would stare at each other. We'd have a little face-off now. Because as soon as I come down, I know he's going to attack me. He says, William, you're allowed to go out of my house, but don't you dare come back. So the two of us end up like, okay, which way is he going? And you do an NFL type fake-offs with each other, trying to get around. You've got to hop over him, otherwise he's going to latch onto your leg and bite you. I do not know why he does this. It's neurotic. Maybe he just likes to see me go and he doesn't want me back in. But this is his MO. He doesn't want to allow me in. So he's saying you're not authorized to come back into the house. When it comes to messaging systems, there's two components. There's commands and events. Commands are where I'm telling you to do something. This is the part where authorization applies. If I'm saying charge someone's credit card $50, you better make sure that I'm allowed to tell you to charge that person's credit card $50. The other side is events. Events come from a place. So I have charged the customer's credit card $50. They can come from one place. If an event comes from somewhere else, that's potentially a problem. So we're going to look at those two aspects here. Within our modular monolith context, let's take a look at authorizing whether someone is allowed to do something or not. I'm going to simplify the diagram a little bit because I want a bit more space on the screen. So I'm going to get rid of the API gateway. It's not really relevant here. All of the other modules besides module A, I'm going to disappear. They're still there. They're just hidden. And that leaves us with a slightly simplified monolith that we can reason about in these diagrams. So how do we authorize whether someone is allowed to send commands? And more importantly, why do we need to do this? Well, on the happy path, everything's fine, right? Module A says, hey, we need to charge William's credit card $50. It goes via the mediator bus. Mediator bus says, oh, this needs to go to module C, put it on the message broker, and the message broker forwards that message to module C. Everything is great. But what if somebody wants to be problematic? What if somebody wants to do something malicious here? What if they've got access to my message broker? Why would they have access to my message broker? Well, you don't know. This is the first part of zero trust within this talk. You don't know how somebody got access to your message broker, but you have to assume that they've got the credentials to get access. Maybe somebody on your team accidentally checked in the connection string. You didn't see it during the code review because they removed it on the next commit, but it's there in the history. Maybe you're working with someone who's disgruntled and they want to share the connection string somehow. Maybe the people that are trying to target you are just that good and they can get access to all of your connection strings somehow. It doesn't matter. You need to assume that they have got access to your infrastructure. So if they have access to your infrastructure, what happens is that they can create these messages and put the messages on the message broker, which then end up at Module C. Module C will take that message and say, oh, I need to charge William's credit card $10,000. Sure thing. How do we prevent this? Thankfully, this is one of the ones that's easy to prevent. We use asymmetric key cryptography. So when Module A sends the message, it says, I am Module A, I'm going to sign this message with my private key. Remember, nobody else has got access to your private key. So Module A signs the message using its private key, puts the message on the bus, goes on the broker, and ends up at Module C. Module C can use Module A's public key to validate that that signature is correct. Which means that if a bad actor has got access to our message broker, they still won't have access to Module A's private key. So they can put a message on the queue, but they can't fake that private key. Which means that when Module C receives a message, if that signature doesn't match any known modules that are allowed to send those messages, we can discard that message. We can prevent people from doing what they are intending to do if they're not supposed to have access to. Now, if you've got a bunch of modules and none of them have been scaled out, you don't want to do this because you're just sending messages on an in-memory bus, and it's way more difficult for somebody to put a message on an in-memory bus than it is for them to stick it on a broker somewhere. So what you want is you want your mediator, your implementation of the mediator pattern to be able to say, oh, okay, this message needs to go externally. Before I put it on the message broker, I'm going to take the signature, the private key for whoever created this message, then I'm going to sign the message, then put it on the message broker. You don't want to do this in the modules because you don't know how many modules you're going to have in your system by the time it's done. So your implementation of the mediator pattern needs to be able to do this for you. The same on the message broker. When a message comes back in, you want your mediator pattern to look at the signature and say, well, I know that this message is supposed to go back to Module A. Did it come from these people who are allowed to actually send that message there? And you can validate that before you pass the message on to Module A. If you're in the .NET space, you have probably heard of the mediator package from Jimmy Bogard. So if you're using mediator, you could do it something like this. He's got pipeline behaviors in mediator. So pipeline behaviors, the code doesn't actually matter. All that it means is that you're taking the private key from somewhere, signing the message, and then adding it as a header, or in mediator's case, an item. And then you forward that message on to the next step. As long as your mediator pattern can do that, that gives you enough information for your handlers to be able to say, no, I refuse this, you are not allowed to do this. And I think cats are probably the best people to say no, because they just say no a lot, for no reason sometimes. So if you sign your outgoing messages, that means that if somebody does have access to your message broker, you can prevent them from being able to put malicious messages on your broker, so you can discard those messages. That's the one half of the coin. The other half is reading. How do we prevent people from reading messages that they're not supposed to have access to? This is another one of Butterbean's favorite places, because during the day, again, there's no dogs. He's got a theme. Bear with him. It's warm and sunny and it's quiet, because even my wife and I aren't there during the day. We work in the office area. My daughter likes to think he's sitting there reading her books while she's at school. Obviously he's not, because not only is he an illiterate idiot, but he's also the laziest cat I've ever met in my life, so he wouldn't put the effort in. So how do we prevent people from reading messages that they're not supposed to have access to? Well, again, let's look at the happy path of how this is supposed to work. Happy path is module A says customer address has been updated, and it publishes an event. This message goes on the mediator bus through the broker to module C, and module C says, oh, great, okay, I'm going to update their address on their stored credit card information. That's fine. That's a perfect use case. However, what if somebody's got access to our message broker? If they have access to our message broker, you have to assume that they are able to set up a subscription on the topics where you publish an event, or they're able to do a bind into an exchange, or they're able to add an entry into SNS. You have to assume that they are able to change the topology so that they also get a copy of the message. So when you send a message saying customer's address has been updated, that message ends up in the inbox of the place where it shouldn't end up. You can still secure that data though, and unsurprisingly, the way to do this is exactly the same as with stopping people from sending commands, just in reverse. So what happens is when module A decides it needs to send a message, it goes, okay, I've published in this event. I'm going to encrypt this message using the destination's public key. So it says this message needs to go to module C, so I'm going to use module C's public key to encrypt the message. So mediator pattern says, okay, cool, I need to put this on the bus. Here's module C's public key. Let me encrypt the message, and I'll put the encrypted message on the broker. It ends up in module C's inbox. Module C can use its private key to decrypt the message, which means that even if the message ends up in an unintended location, that location doesn't have access to module C's private key to decrypt the message. Both of these are fairly straightforward, and if you're using an implementation of the mediator pattern that has behaviors, again, the code doesn't actually matter. This is just taking the message body, encrypting the message body with the appropriate key, and then replacing the body of the message with the encrypted body before letting the mediator bus do the rest of the thing that it has to do. If you do this, even if your cat isn't an illiterate, lazy idiot, it still won't be able to read the messages that you've sent across the wire. The core concept with both of these is zero trust principle, where you have to assume that somebody has got access to your infrastructure already. Is anybody working in the PCI space? Right, so a lot of this applies there, where you just assume that there's no actual safe environment that you've got. You need to make sure that if it isn't safe, you still need to do your best to mitigate things. So I said there was half of it was reading, half of it was sending commands. That's not true, because there's another half. I like to give 150%. So the third half is someone can just be malicious in your system. Cats like to just knock things off. I don't know if this is an evolutionary advantage that they've managed to develop, but they're really good at it. And I don't know how it became a thing that they do. They just like to be completely malicious and destroy for the sake of it, which means that somebody can get access to our system. And if we send a message and it goes to the intended destination, great. However, if they've got access to our message broker, they can connect directly to the queue that should go to module C. So instead of adding a subscription to a topic, they would just they would just consume messages from the queue as a competing consumer. When a message comes, there's a chance that that message could end up in the bad actor's inbox, in which case they can just discard it. How do we prevent this? This one's a little harder, because while we could prevent them from reading messages, and we could prevent them from putting malicious messages onto the queue, or we can't prevent them from putting them on, but we can ignore those ones, we can't really stop them from consuming messages from the queue if they have access to the broker. What we can do, though, is we can reduce the potential impact of that by using dynamic credentials. What do I mean by that? So Hashik Vault, for instance, has the ability to create dynamic users for infrastructure that you're working with, whether that's a SQL database or a RabbitMQ client or a Azure protocol. You can request, instead of a connection string for a resource, you can request an identity, an entity that has now got access to it. So you make the request, Hashik Vault will go and create a new user and password and give you those credentials. You then use those credentials to connect to the resource that you were trying to connect to. The clever part here is that those credentials have a time limit. The documentation from Hashik Vault starts with 7 days as a default, but you can take that down from 7 days, 3 days, to a day, a few hours, maybe an hour. You can go with Hashik Vault as low as a few minutes for these dynamic security credentials. Now, I'm not saying that you have to go and use Hashik Vault everywhere. I'm not a spokesperson for them, but I'm saying this idea is interesting, and you can implement this yourself somehow. So if you were doing RabbitMQ, for instance, you could create a user with permissions with these two API calls. You just make a request to the management API, say, give me a user, create a user with this username and this really complex password, and here's the permissions that they need to get. If you can host this in a very secure way, you can then have dynamic users that get created as requested. And then in an hour's time, you can go and change the password for these users so that if the credentials are leaked, people can't use them again. This is 2 network calls to do this. You could get a little smarter with this. So you could have a pool of maybe 200 users with already predefined security credentials with just completely random passwords. And then instead of having to create the user and set the permissions, you could rather just take one of the ones that are unused, overwrite the password, and then return those. So you could shorten this. You could also do this in the background continuously so that you've got a continuously rotating pool of credentials that are changing the whole time. There's ways you can make this really fast because the provisioning of security credentials could take a couple seconds sometimes, often not, but if you're doing it often. But you can make this a little bit faster. On the Azure side, maybe you can do the same thing. You can provision users. No, do not. You cannot because it takes minutes for users to be provisioned. What you can do with Azure and with SQS is you can do dynamic token rotations. So instead of having a user that gets created, you use Azure's Key Vault to continuously rotate the SAS tokens that you're using to access those. And then when your client code says, well, I need a token to access this resource, instead of using a token from an environment variable somewhere, it requests a key token from Key Vault. Key Vault says, here's your key token. It's going to work for 3 minutes. And then you use that to connect to the resource that you wanted. So dynamic security credentials is an interesting way to decrease the potential impact of leaked credentials, because it means that if somebody does get access to those credentials, they can only do whatever malicious impact they wanted for the period that those credentials are valid. It does, of course, mean that you have to make sure that whatever is doing the provisioning of these resources is completely secure. In the Azure and SQS space, or Azure and Amazon space, both of their key vaults can do this for you. If you're using Hashik Vault, it does it for you. If you're rolling your own, please be extremely careful, but it is possible.
Is there a way to sort of have like a correlation idea on those messages, and sort of if it wasn't action, then the message broker would know, and if it wasn't action properly, then it sort of sends it back to the sender?
So the question is, could you have a correlation ID on the message so that if there was something wrong with that message?
It never got action, it went into a black box and never got discarded, so never reached the receiver. Then is there a way that the broker could know about that eventually?
Yes.
Go back to the sender and say, hey, that message never got it.
Correct, you can. So if you have, and I discussed this in my workshop yesterday, if you've got an implementation of the outbox pattern, you can definitely do that because you know that this message has gone out, but you know that it's never been received on the other side. So you can do that, yes.
What's the pattern?
Outbox pattern, yeah. If anybody wants to talk about that afterwards, you're welcome to come and grab me too. Let's talk about personalization of security. So I said personalization is you've got authentication. This is William. Here's my passport proving that I'm William. Authorization is here is William. Here's my passport. It's got the visas of which country I'm allowed to enter. And this is William. He's in Australia, but because he's got a passport, he can't buy property. He's not a citizen yet. He doesn't have permanent residency. So it's slightly different behaviors. Maybe William is allowed to see all of the transactions for the day, but he can't see the credit card numbers for those transactions, or he can't see the dollar amount of those transactions. It's a security aspect that changes how the UI works. An example would be one of our modules publishes an event that says this order has been shipped. Now, I don't know if Australia's got the same thing as Europe or South Africa, but in Europe you've got GDPR, and in South Africa we've got the POPI Act, which says if you get access to identifiable information, you better have a good reason for needing that information. So a message like this, if I publish it, the people that are going to get this message are going to get the address of the person, they're going to get the email address, they're going to get the contact number. Not everybody that subscribes to this message has got legitimate need for that information. So we need a way of personalizing this message so that only the people that are supposed to have legitimate access to this information are able to read it. And remember, when you publish an event, you don't know where that event is going to go. You don't have that knowledge yet. There could be subscribers 10 years down the line that suddenly appear for that information. What we can do with this, though, is we can say, well, we've got these bits of information that are sensitive. So let's decorate them with an attribute, sensitive. We'll say that these properties on this object are sensitive, which means that when this message goes out, we need to do something with them. So in our implementation of the mediator pattern, we could go through all of the properties on the object before we send them out, look for the ones that have been decorated as sensitive. If they are sensitive, we can choose a key to decide what to encrypt those values with before we send them on. And we replace the current values with the encrypted values of those, which means everybody's going to get a copy of this message, but only people that have got access to the key to decrypt those properties are going to be able to read that bit of information that's available. The nice thing about attributes is that we can add additional properties there. So we can say that, for instance, this should be readable by people that are in the dispatch role because they need to know spot what I've been talking about for the past 2 days, where the package has been shipped. The customer service needs to have access to this property, but not to the other properties. So we can be granular in terms of what key must be used. If you do something like this, you do need to have multiple keys in place. So you need to have, in this example, a dispatch key, as well as a customer services key, and a customer service dispatch key, which everybody that's in customer services or dispatch must have access to. But by being able to decorate the properties of messages with who must be able to read them, you can make that sensitive information visible only to people that have got access to that. And that's known as partial message encryption. With that in place, only the people that know what to do with that information are going to be able to access that information and do something with it. Let's talk about token expiration. Butterbean likes getting his belly scratched sometimes, and the offer is only valid for a certain period of time. You don't know how long that offer is valid for. It could be a minute. It could be a few seconds. You only find out as you put your hand on his belly and you start scratching and you realize this was a big mistake because he will latch onto you and use his back paws to try and rake your arms so that the insides of your body are on the outsides of your body. Which is problematic because the inside of my body is where I keep all my blood and stuff. When it comes to message-based systems, this is important because if we take a message and we send the message, it goes along the broker to the destination and everything is fine, except the only control we have is sending the message, when we send the message, which means there could be another message in the queue in front of this one. There could be lots of messages in the queue in front of the one that we send. So we don't know when this message is going to get processed. If we send this message and it ends up at the back of a very long queue, by the time it gets to the front of the queue, the token that we used to authenticate that this person is who sent this message and this token is valid, it could have expired. If it's expired at this point, do we honor the token? Do we do what the message says? Or do we discard it? There's 3 approaches that I know of that you can deal with this. The first is you can just forward identity along with the message instead of using the token. You can then also use a custom data structure which extracts information from the token, or you can do a token exchange along the way. And we're going to go into all 3 of these now, and we're going to see what the reasons are you might choose one over the other. None of these are better than the others. They're all just different ways of doing similar things. Forwarding identity. So when a user accesses our system, they've got their identity there. And at the beginning of the talk, we addressed this We addressed forwarding identity by simply taking the user ID and appending it to our messages. So we create a message, we add the user ID, and we send it along. That's the same as just sticking the user ID property on. This works. It addresses the problem of token expiration because we know that William triggered this action, and William has got access to trigger this action. We should honor it. The downsides to this approach is that if somebody's got access to our message broker, they can intercept these messages and get the user identity from one of those messages. Then put that user identity on another message and pretend to be that person, assuming that we haven't done the sign-in and encryption of messages as well. So the pros of this is that it's easy to implement. The cons, depending on what sort of threat model you're under, it may not be sufficient in terms of securing your system. What about a custom data structure? So the custom data structure says, well, we've got the user's token as they access the system. When I create the message, I take bits and pieces from that custom data structure and I put it into from the token and I put it into a custom data structure. That custom data structure would include who the user is, as well as what roles and permissions that user's got perhaps, or the claims that they've got, and then a hash of these claims so that you know that somebody hasn't tampered with this message at all. This works well because it means that you can also do granular permission level sets of who's done something or who's requested an action. Somebody can still get access to this object and put it on another message. We can address that though by making the hash that we include also include the original message body. If it includes the message body and the username and the claims that the person has got, that means that we don't have to worry about securing the message, or we don't have to worry about somebody taking that message, that user identity object and putting it on another message.
Can you explain that again? What's the difference? Why would you want to be able to do that?
You wouldn't? Okay, so the question is, can I explain the difference of that? So the difference is that if you've got the user identity object and the hash in the user identity object also includes the message ID and the body of the message that you're sending, if somebody gets access to that user identity object and they put it on another message, the hash won't match because the body of that message has changed. So if they validate the hash of that message, the hash includes the message. And then the third approach is to do a token exchange. And the token exchange relies on the idea that you've got external system security and internal system security. So people that are accessing your system externally, you need to be more careful about how you validate them. You need to have shorter expiration with their tokens. But once they access your system, now when you send a message internally, you are in the bounds of your system. Maybe you can be a little bit more lax with how long the token expiry is. So what we would do in this case, we would take the user's token that they presented to us, and we would replace it. We would exchange it with a system token, module A's token. So we would take the user's token and we'd replace it with module A's token, and then send that message along. The key elements that module A's token would have is that it would have a longer expiry because it's internal to our system. We think there's more trust that we can have within our system. It also has to have a hash of the message that's going along with the object because you don't want people to be able to tamper with the message. It must also include the ID of the message, because if you are retrying messages or re-enqueuing messages, that's a new ID, and you have to have a new token at that stage as well. So even if the body of the message is the same, the ID of the message needs to match. And it could be a refresh token. So refresh tokens, depending on what you're using for your token provider, some of them have what they call refresh tokens, where you just make a request somewhere and it gives you a new token based off of the original request. So those are three ways of dealing with token expiration. The takeaway here is that I just want you to be aware that tokens can and will expire in your system, so be aware of that and think about how you're going to address that. If you process a message with a token that's expired, what should you do? If a system takes a really long time to respond, you need to be able to recover from that system not doing anything even later so that you can still process messages. What about when things change? So security is often not static. You might have different business requirement rules that change. Poor Butterbean has gone through a lot in his life. When my wife and I got him, he was obviously a kitten. We didn't have dogs at that stage. We didn't have kids. They've all come and made him extremely miserable, except for my one daughter, who made his life worth living. That horrible, horrible cat. When it comes to how you deal with version changes or security version changes in distributed systems, it's a little bit complex. Because if you've got a certain security contract on a message and you send it along and it gets processed, great, that's fine. Both systems know how to talk about this. But when things change, so if you say, well, I'm going to deploy version 2 of my main application, and version 2, the big change here is that instead of sending this information in this object, I'm going to mark one of these properties as sensitive. I haven't changed really the structure of the message, it's still the same schema, but only people that are in the billing role are going to be able to read this property of the message. If I put that message on the queue, module C, when it receives it, needs to be able to work with the new version of the system. So we can do this quite happily. We can just deploy the monolith and module C at the exact same time, because now they both have the same version of the contract, right? Yes, that's fine, except it's not. The reason it's not is that there may be older messages in the queue that have the old format still. And then you put in new messages in the queue that need to be processed. So you've got both schemas of the message in the queue. The recipient of that message needs to be able to understand both versions of that message. If it doesn't, something's going to fail when it tries to deserialize the message. So even if you deploy your entire system, including all of your external modules at the same time, you're still not guaranteed that both of them will be able to talk the same language. So what we need is, instead of our mediator bus having one set of keys that it works with for every module that it deals with, we need something smarter there. We need it to be able to deal with multiple keys, for instance. And when we send a message and we encrypt a property on a message, we need to also include which key ID was used to encrypt this message. So that when the message is received, we can go and say, oh, it's key ID 1. I know where that key is. I'm going to go get it. We can use that to expire old keys. So we expire key 1 and we replace it with key 2. Key 1 can still be decrypted, but nobody can re-encrypt messages using key 1. And when we send any new messages, we say this message has been encrypted using key 2. You can go and write this all yourself, but all of the key providers in the cloud space currently do this for you. So just use something like KMS or Azure Key Vault or Hashik Vault. And when you send in your messages, if you are encrypting data on those messages, include the key that was used, the ID of the key. And then in all of these key management tools, you can then go and expire those keys very quickly and rotate through them. And your code doesn't even really need to know anything about that. These key management tools are fantastic, and it's a great way, if you're constantly changing your keys, to make sure that even if people are trying to get access to your system, it's going too quickly for them to do anything too malicious for them. So make sure that the middleware you're using is able to decrypt using different types of keys in a system. So those are the 6 things that we've looked at so far. So we've taken a look at why you should include identity and different ways that you can include identity in your system. We've said that if you want to, you should sign messages. You can encrypt messages as well. We've also taken a look at partial message encryption and why that might be useful, as well as what you need to do to plan for token expiration in your system, and why a key vault is a really useful tool. I am not here to say you have to use all of these. These are just tools that you can use in your system if it's applicable. If you start thinking, well, I'm in an environment where I'm dealing with finance, maybe I need to be cognizant of the fact that zero trust is the thing. If I assume that somebody has got access to my environment, what can I do about it? Is there anything that is useful? Is the cost of doing this low enough that the benefits are sufficient? The only one of these that I think is maybe valuable for everybody to do is to just include the user ID in any messages you send straight from the beginning, because it's so low cost and the benefits, even if you don't scale the system out, are really worth it. And if you follow these, you might also be able to keep your secret precious little toy safe from the world. This talk was originally going to be entirely cat memes. It wasn't going to have Butterbean in it at all. But unfortunately, while I was preparing it, he passed. And I thought, excuse me, what better way to honor his memory than to get up in front of a room of people that didn't know him and tell them what an asshole he was. Thank you. Are there any questions? I do have time. Otherwise, you can grab me outside. I'll be around for the rest of the conference. Thank you.